Hi, so in this video we're going to cover nominal moments and plastic section modulus required, and we'll end up by selecting a beam that handles the moments that we need it to handle. So before we watch this video, you should have watched already establishing the loads and the video on MD solids, but we're going to go through this anyways. So we're going to calculate our nominal moment, which is Mn, and from MD solids we have our actual moment, and we have a factor of safety for this. So my nominal moment is equal to, from MD solids, my actual moment was 40,500 foot-pounds. And my factor of safety for moments is 1.67. So my nominal moment has to be greater than, or actually has to be equal to, or is equal to, 67,635 foot-pounds. And so this factor of safety just makes sure that when I load this beam up with my 40,500, I've gone above and beyond in my design, and this is not going to reach its yield point in the steel, and it's not going to fail. So the next step is to take this nominal moment that we have and put it into a number, convert it into a number that we can look up on a table and actually select a beam to do the job. So the plastic section modulus, or Zx, is what we're going to use to calculate the plastic section modulus, and we're going to find a beam that has a plastic section modulus greater than the nominal moment divided by the yield point of steel. So the yield point of steel is a given number for most equations. In this one, we're going to use 50,000 psi. So my plastic section modulus has to be greater than or equal to that 67,635 foot-pounds divided by 50,000 pounds per square inch. So we have a little bit of a unit problem here. And the unit problem is that I've got feet here and I've got inches squared here, and I need this to cancel out because I don't want it to be foot inches squared. I want this to be inches cubed for my plastic section modulus. So what I need to do here is do a little bit of conversion, and since the foot is on the numerator, I'm going to put the feet 1 foot in the denominator and 12 inches in the numerator, and the feet then cancel out here, and I end up with inches cubed for my final answer. The pounds will also cancel out. So the Zx, or the plastic section modulus, has to be greater than, once I do all this, 16.23 inches cubed. So now that we know what our plastic section modulus has to be greater than, now I can go to a table, and I've downloaded this table off of structuraldraftingNetExpert.com. You can see that right at the top here. And to get to this table, you'll click on steel sections, and we're particularly looking at wide-flanged beams. And I've already highlighted in yellow the beam that does the job. The column that we are interested in is right here. This is my ZX. Let me relabel that guy. That's my ZX, or my plastic section modulus column, right here. So as I go down, I'm looking for a number that is close to 16.23, but larger than it. And the first one that I see as I go down this table, scroll way down, is find the 17.4. So as we go down, there's actually another one that's 18.7. It's down here at the bottom. And if I follow this all the way over to the left, it shows me a beam. So let's follow both of these all the way over to the left. This beam is W10 by 17, so it's 10 inches tall, 17 pounds per foot. This other beam that I have up here is a 12-inch tall one and weighs 14 pounds per foot. So that's actually the one we're going to pick. This W12 by 14 looks pretty good. It's not too heavy, and the reason I picked this is because it's 14 pounds per foot instead of 17. It's a lot lighter, all right, per foot. So that W12 by 14 is the item that we are going to use. So I go back here, and W12 by 14 beam is what I'm going to select. The next thing that next video you'll want to watch is nominal shear, and selecting and making sure that this W12 by 14 does the job for shear.